We're recording.
Okay. So let's talk about what's going to, so this is kind of relative to the lab today, okay?
All right, we have a lab.
So it's 1 meter, this is 20 degrees, this is 20 degrees, right? So the first thing that you have to figure out is what are the forces acting on each ball, okay? So you've got a gravitational force acting down, right? So that means there has to be an equal and opposite value of that acting upward, right? So you know that you know the mass, they're what, 3 grams, whatever they are, okay? They're like 3 grams, right? Okay, it's cool, you got 3 grams. So then you can find that side of it, true? Now, you also know that this is a 20-degree angle. So there's also going to be a side here that's that electrical force that's pushing this thing away. Okay? So look at it this way. You have an angle of 20 degrees, so you know an angle. You know the mass, so you can find one side of it. Then using trig functions, then you can find the value of the electrical force, that opposite, that horizontal side, that's pushing it away. So on 64, so when you find that electrical force, okay, because if that's wrong, the next part is going to be wrong. So that should be something times 10 to the minus second, okay? So that's the force that's pushing this thing apart. Use tangent. Let me give you a hint. Okay? Because you know tangent is opposite over your adjacent. Okay? And when you look at, depending upon if you work on that 20 degree or if you work out here on that 70-degree angle, it's a personal preference thing. Okay? So you can find, you know the angle, you know the side adjacent, you can find the side opposite, which is what that electrical force is going to be. So then, once you get that electrical force, okay, that equals K times Q1 times Q2. Now, the whole key assumption here is that they are equally charged. So that means the two Q's have to be the same, right? So you can have Q1 and Q2. So those are your unknowns. So since they're equally charged, you take Q1 times Q2, you get Q squared, not 2Q. Okay, you get Q squared. And then you solve for Q, and what you should get is something times 10 to the negative 7th coulombs.
Yep.
Or if you're in nanocoulombs, it's something close to a very, very big airplane.
I need explanation. I don't get the joke. 70.
Oh!
747. It's something close to...
Boeing airplane.
Wait.
One of the more famous.
I got.
In nanocoulombs.
Is that the one that kept crashing?
No, that was their new
So it starts. Does it start with a 7?
Yes.
Okay, so I think I have half that value.
You got the mass of the Death Star.
Huh?
I got the mass of the Death Star.
Okay.
He's confused. That is false.
Yeah, no, that makes sense.
Okay.
And then
On 66, that angle
Oh, that's right.
should be something in the low teens.
Or 66?
66. And on 68, in centimeters, it should be around 5.
It's taking like 3 hours.
Probably the hardest one was 38. Okay?
3.7.
Just because you had to do so many steps.
Negative 7.
And then negative 7.
Because you on 38,
3.37 e to the negative
what's
7.
that ultimate answer on 38? What
it's
fraction
just
of its
around it.
electrons have been
Okay.
removed?
Mr. Burkamp?
What?
Okay, so Mof B and Mia got 3.73 times 10 to the negative 7 for 64.
Did you say 38?
I had to look up so much energy.
Is that precisely half the answer? Or like roughly?
See, that's what one
What do you have as your electrical force?
0.0107.
Yeah.
Yeah, and then that equals KQ squared over R squared.
Yeah.
And you solve for Q.
You multiply that by 0.342 squared, it's 0.00125. And you divide that by K.
Then you find the square root of that, and that gives you 3.73.
Yeah,
Yeah. You have to do.
that's the right answer.
That's what we did.
I don't know.
Yeah, so I've got enough.
We have our, okay, this one.
The radius is 0.342, right?
On which one, 64?
Yeah.
No, it's .684.
Ah, it's half that. Oh, it's twice that.
Okay.
Okay. That would explain it.
Yeah, because that's,
Oh, that's why. Distance.
Yeah. I know, it would just end up being twice the value, so.
yeah, 38, you have to do a whole bunch of, you gotta find the density and then the mass and,
Molar mass of copper, convert it to.
a whole bunch of stuff.
Convert it to moles
And
of
then there's 29
electrons.
electrons and, so if all goes well on 38, your total number of electrons should be something times 10 to the 22nd.
I concur.
It should be like, so 64 is 7.45, roughly.
Huh?
7.45.
Total
Yeah.
electrons, not the fraction.
Oh,
Wait, it's a fraction.
Huh?
it asks for a fraction, which
Which
is
one?
38.
Yeah, and it's gonna be a really small number.
Is it okay if I gave you percentage?
Huh?
Is it okay if I gave percentage?
Yeah, I just wrote mine as a decimal.
Yeah, it's a decimal, just leave it as a decimal. It doesn't ask for a percentage. On 38, it asks for a fraction. It should be something times 10 to the negative 11th.
Okay, well then,
Yep.
yep.
Okay? As a decimal, it's something times 10 to the negative 11th. No, it's grams per minute.
I made this joke.
Okay, anything else?
Are you sure it's not negative 12?
Yeah, it's.
So, the one you
It's kind of getting in my space.
I'm sorry. I'm so sorry. I figured it out.
And I solved
You have times 10 to the 20 up here.
Okay.
Because I erased it and redid the numbers because I'm trying to write it like yours because apparently I did something wrong with the multiplication and even though we've got the same numbers we ended up getting different e to the power because my calculator is ancient!
They don't. Keith, you know what the word for debate is? When people do this. If you want to know how to really do that.
First time around.
Oh, it's so good. There's nothing.
I heard that, and I read
Oh yeah, I did that with Keegan. We just go.
And that's not right.
Conversions.
Probably less germs spread that way.
I have to redo.
There's
all
nothing
of
worse
them.
than a bad handshake.
That's really fun.
Yeah.
And debate is filled with them. It's awful.
Now, if you're in southern Africa, especially in Botswana, when you shake hands here, so if you're in Botswana, you take your left hand and you put it on your elbow like this when you greet someone in a formal setting. Because the idea was that
You can't
because
pull
it's
weapon.
kind of like a warrior tribe background.
You can't
That
pull
way,
weapon.
if you've got your hand like this, you can't be holding a knife or something in in the opposite.
So you can't.
Holy cow!
You can't do the
That was
handshake and
traditional.
stab him in the gut.
So if you do that, then you know there's nothing.
Oh, yeah, there we go, he stabbed me.
Oh, that wasn't. That's not very.
No, please stab me through the back.
I stabbed me.
No more stupid calculator
Okay.
steps.
So this lab that you're gonna do for the next 2 days,
Oh, yay!
and I want groups of 4. I want 4 groups. Okay. I want 4 groups, not 3. I want 4 groups. So here's the deal. So what you're gonna do, and I'm gonna tell you right now, you're gonna get probably a little frustrated in this lab. Welcome to electrostatics. I'm just telling you.
Is this like the tape lab?
Huh?
Is this as bad as the tape lab?
Because that made some people very angry.
I almost cried.
Probably, it'll rank up there.
Oh
Am
no!
I gonna cry?
Yes.
We're gonna cry.
Okay.
Yes.
Our blood, sweat, and
Because
tears
it's
are
gonna,
going.
you're gonna tie a whole
And I
bunch of
will
different
enjoy your
things
games.
together in this lab. So here's what you're gonna
You're not a
do.
teacher. You
I
can't
got a
do
whole
that.
bunch of different colored balloons over there. The balloons are of your choosing. Okay, whichever colors you want. If you like matching balloons, if you want different balloons, I don't care. It's up to you.
There was an old thing.
So you're gonna blow up 2 balloons, and then I've got thread. And you're going to charge with yonder blanket. You're gonna rub the balloons, and you're gonna charge them, okay? And you're gonna have the balloons hang from a thread like this, okay? So once they're charged, just like I did before, because they're gonna hang down, so in some regards, it's like the assignment that you just did, okay? So what you're gonna try and figure out is a whole bunch of different things, okay?
Whole bunch of who?
Whole bunch. So you're gonna hand in 1 write-up per group, okay? So it's gonna be typed, so figure out who's gonna do the typing or how you're gonna merge the document together. So you're gonna measure whatever you need to measure, okay? I don't care if you measure the length of the strings, I don't care if you hold up a protractor to measure the angles, I don't care if you hold up a protractor and project the image onto the wall and measure the angle that way based upon the shadow. I don't care, okay? There's a whole bunch of different ways that you can get the dimensions, okay? But herein lies the frustration. In case you haven't noticed that when you do this, and if it's charged, and it's dry air today, that you're going to have a large amount of electrostatic force. And so it's kind of like the Heisenberg uncertainty principle in the sense that by making the measurement, you have very much the potential to disturb the system, okay? Like with the Scotch tape lab and the balloon. So you have to be careful that when you're measuring and you're doing these interactions that it isn't, you're not affecting it too much, okay? It's going to be tough to do unless you're going to build like a really big, big long meter stick apparatus, and you're going to stand like, 5 meters away and you're going to measure it that way. And it has been known to happen, but
Really?
no,
Oh.
not 5 meters away. But apparatus has been built before too.
In here?
Huh?
In
Yeah,
here?
Yeah, just to get the measurement.
You just need to tape a couple like rulers
Well,
together.
just, I know, just. So, anyway, so you're gonna hand in 1 per group, you're gonna measure a whole bunch of different things. I've given you what I want you to use as the density of air, 1.20 kilograms per cubic meter, okay? Yes, you're gonna have to deal with buoyant force. So, you wanna calculate a whole bunch of different things. You want the charge on each balloon, and I laid this out. The number of electrons gained or lost on each balloon, okay? So you got that. The gravitational force between the 2 balloons, okay? Like, there you go. And then the fraction of the gravitational force as a fraction of the electrostatic force, okay? So you're basically going to say, here's my gravitational force that's holding these 2 balloons together. And then here's the electrostatic force that's pushing them apart. And as a fraction of that gravitational force, here's the electrostatic force, okay? This is a fraction, not a percentage. So then what we're going to do is we're going to make one big data table and then we'll compare the numbers from all four groups, okay? Now, take your time, literally. You have no homework tonight. You're going to hand in one per group. So this is what we're going to start today, and we're going to work on it today, and you've got tomorrow as well. So just keep that in mind, that this is all about the process. Think through, like, even if you, obviously you're going to need like the mass of the balloons. Okay, when do you measure the mass of the balloons? Think this through. Do you measure the mass of the balloons before you fill them with air? Do you measure the mass after you fill them with air? If you measure the mass after you fill them with air, how do you take the buoyant force into effect? Okay? Because if you already fill this up with air and you set it on the scale, is that going to be a true representation of the mass of the balloon and the air that's inside?
Better than nothing.
But it's also minus the buoyant force.
Yeah, that is better than nothing. But
Definitely
as
not
opposed to
wrong.
just guessing and going, oh, it's a half a kilogram.
That's a heavy balloon.
It is. So that is.
The weight of roughly
So-
0.7
But you still use 10.
So those are some things that you want to think through. Because especially when you go to calculate the gravitational force between those two balloons, you have to have the absolute mass of the balloons to calculate that gravitational force. Okay? So, for the sake of argument, you can assume that the balloons are equally charged. Okay? Because if not, then that's going to get real ugly because you don't know which one's more and which one's less. So you can assume that the two balloons are equally charged. So I've got thread. What some people, and again, I'm just telling you some options. What some people do is they'll tie each balloon to a string, okay, and then hang it down, because I've got like, I'll take that down, like I've got like some hangers that are up there in the ceiling, okay, and you can move them around to wherever your group wants to work. Some people like to just tie one big, long, massive string and make it symmetrical that way, okay. I don't care what you do. This is all your decision in terms of how you're going to pull this off. Okay? Whether it's one big long string or whatever, make sure that you keep track of, you know, if you're going to differentiate between the balloons, which one you can mark on them, which one are you going to call balloon 1, which one are you going to call balloon 2. Are you going to blow them up to the same size? Are you going to blow them up to different sizes? Is that going to be something that you're going to worry about in terms of, we want these to be the exact same? Or is it okay if there's some variance on it? When you charge the balloons with the blanket, make sure that you try and get those readings right away, because obviously after they sit there for a while, I mean, so it's going to get discharged. So when you charge those balloons, try and get your data relatively quickly. Now, it is going to be significant enough. Are we good?
Yeah, I was just trying to figure out if I should turn the camera or not to look
Oh,
at
no,
the
you're good.
balloon.
But here's going to be the potential problem, is if those balloons actually do come in contact with you, that's going to be like a pretty big discharge of those balloons, okay? In terms of being affected by the number of electrons, because those electrons, if you actually touch it, if it comes near to you, you're okay. But if it actually touches you, then you're going to distribute those electrons over that, and that can make a pretty significant difference in those values. So if that happens, you might consider like recharging those balloons, okay?
We're getting shocked a lot today, aren't we?
Well, not necessarily shocked, but
That's not going to be that
We're
much.
getting shot.
shocked.
Just
Shot.
Okay,
Stab.
so let me have this out.
Stabs while shaking someone's hand.
You shoot someone with a knife.
Do you want me to turn it off?
They've been shabbed.